When you have an Euler form, you need to know the following fact, that r times e to the theta I is just another way of writing down r angle theta, or this in turn is just another way of writing down r times cosine theta plus I sine theta. So why write it this way? Well, it comes from the fact that we have this Euler identity. E to the theta I equals to cosine theta plus I times sine theta. This is called the Euler identity. And this is used to prove the fact that if you have r1 angle theta 1 times r2 angle theta 2, the two sizes, or the absolute values of z, the absolute values of the complex number, multiply, r1 and r2 multiply, whereas the angles add. Now this very amazing fact is proved by using this identity. So you can rewrite this as r1 times e to the theta 1I, and this can be written as r2 times e to the theta 2I. And if you multiply, well, r1 times r2, you can just write that first. And then if you use the fact that exponents add up when you multiply, this becomes theta 1 plus theta 2 times I. And that's indeed same thing as this, right? So that's the easy way to prove that this is true, once you know the Euler identity, of course. Now, to actually do these questions, we will have to just make use of this formula right here over and over again. This is all you would need. Okay, so you have 2 times e to the pi over 3I. You just say that's equal to 2 times cosine pi over 3 plus sine pi over 3I. It's important that you don't put the I inside the sine or cosine. The identity is that it only appears once right here. I is not included in the theta, right? And you should know that cosine pi over 3 is 1/2, whereas sine pi over 3 is radical 3 over 2. And then when you multiply 2, you get 1 plus radical 3I. And indeed, this is an a plus bi form. Okay, let's move on to the next one. E to the 5 pi over 4I. If you don't have anything in front, think of it as like 1, okay? So this is really like 1 angle 5 pi over 4, just like that. But we only need to use the r times cosine of this angle plus I times sine of the same angle. And if you go to the unit circle and draw this 5 pi over 4, which is 225 degrees in degrees, radians, 5 pi over 4 radians is 225 degrees. And over there, the x and y coordinates are both negative, and there they are both same, right? And we know that if sine cosines are same, they both should have the value of radical 2 over 2. With plus or minus, you have to determine later, but in this case they're both negative, so it would be both negative radical 2 over 2 and negative radical 2 over 2, so it's going to be 1 times negative radical 2 over 2 minus radical 2 over 2I. So that will be your answer. Now this last one is a little different than the others because you have this plus 1. So that's not in the form of something times I. In that case, you have to split that into 2 multiplications, because if you multiply these two, the exponents add up, so these two are the same thing. You can go backwards, right? And because these two are the same thing, now I can just have one form that looks like the Euler identity and the other one a regular exponent. The one that looks like Euler identity, we use the Euler identity. Cosine of pi plus I times sine of pi, and then times e to the first power, and cosine pi is -1, whereas sine pi is 0, and -6 times -1 is +6, so you have 6e as your answer.